Welcome back, guys. In today's video, we're going to be covering the concept of waves. Now, there are many different types of waves on the electromagnetic spectrum, including infrared waves, UV waves, and waves of visible light that we can see with our own eyes. Now, there are some important concepts related to waves that we need to go through. So the first is wavelength, right? Now, wavelength is measuring the distance of a complete wave cycle. Right? So if we look at this wave right here, what we're going to do is find two crests of that wave, right? These are crests right here, this elevated portion of the wave, right? And if we measure the distance between these two crests, what we have is a complete cycle of that wave, right? And the distance between these 2 points is the wavelength. Now what we want to do is measure that in meters, right? And the symbol for wavelength is the symbol right here. It's called lambda. Not too important, but if you see the symbol, it is referring to wavelength, right? So another important concept when it comes to waves is frequency. Now, frequency is a little bit more tricky to explain, but the way that I do it is I like to draw a line right through the wave, and I like to imagine that this wave is traveling to the right. So imagine this wave is traveling to the right. It's not just sitting here static on the board. Now, what frequency measures is how many complete waves would pass through this point, this red line that I've drawn, how many would pass through this point per second. So frequency is measured in reciprocal seconds, right? 1/seconds. So let's say that 3 complete waves were able to pass through this red line in 1 second. The frequency would be 3, right? Now, if we do the same thing down here, what would we notice about the frequency of this wave? Now, this has a much longer wavelength. That means a smaller number of complete waves are going to pass through this point per second, making it have a lower frequency. Now, one important thing to note, now that we've talked about both of these things, we can see that as the wavelength increases, your frequency is going to go down, right? Because the longer your wave is, right, less complete waves are going to be able to pass through a certain point per second. So that's to say that wavelength and frequency are inversely proportional, right? The longer your wavelength, the lower your frequency. And if you have a very short wavelength, a very short choppy wave, right, it's going to have a very high frequency, right? So the last thing we need to talk about is the velocity of a wave, right? And if we're dealing with a light wave, we can use this formula, right? So C equals lambda times this symbol frequency, right? This symbol right here, this V looking symbol, is the symbol for frequency, right? So C, if we're dealing with a light wave, is the speed of light. Now the speed of light is constant. It's 3 times 10 to the 8th meters per second. So if we're dealing with a light wave, as long as we know one of these two variables, we can solve for the other one because we'll have the speed of light as 3 times 10 to the 8th meters per second. So let's go over here and tackle our practice problems. So the first question says, what is the relationship between wavelength and frequency? Well, as we saw before, as your wavelength increases, your frequency decreases, right? Long waves have a very low frequency, right? And short, choppy waves like this one have a very high frequency, right? So that is that inverse relationship between wavelength and frequency. Now, the second problem says the wavelength of green light is 500 nanometers, right? So this is nm, so this is meters. This n is for nanometers, okay? Nano, the prefix nano, is 1 times 10 to the negative 9th of something. So we're going to have to keep that in mind. Calculate the frequency. Well, this is a light wave, right? And we can use this formula, right? So C, which is 3 times 10 to the 8th meters per second, right? That's the speed of this wave. It's a light wave, right? The wavelength, right, is 500 nanometers, right? However, I want to get that to meters, right? I want my wavelength to be in meters, not nanometers, right? So this is and the reason I want to do that is because this is meters right here. If I have meters right here and nanometers over here, the units are not going to agree with each other. We're going to get the wrong answer. So the wavelength is 500 times 10 to the negative 9th meters. That's how you convert nanometers to meters. So all we're left with is our frequency. Okay, so if we divide 3 times 10 to the 8th by this 500 times 10 to the negative 9th, our frequency will be 6 times 10 to the 14th 1/seconds, or reciprocal seconds, and that is the correct unit for frequency. So we talked about wavelength, frequency, and how to use this formula. I hope you enjoyed. Thanks for watching, and make sure to check out more videos on the channel.